Solve some more quadratics here. So for these ones, it doesn't tell you what method to use. And so here's what I'm going to say for all of these. First, you're going to get one side to 0. And we did that before with either technique. And then I'm going to say try factoring. Factoring will work sometimes. Sometimes it will not. If it does work, it's going to be easier. And then if it doesn't work, then we're going to switch over to quadratic formula. So, yep, that's that. All right. So, number 12 here, you can see we already have one side to 0. So, I'm going to try factoring now. So, we're just going to do our x here. We're going to do a times c up top, b on bottom. So, that's going to be negative 10 on top and negative 2 on bottom. So, I'm thinking of two numbers to multiply to 10 or negative 10 and add to negative 2. So, for 10, we have 1 times 10. And 2 times 5, neither of those is going to make negative 2. So that means that the factoring does not work. You can't come up with two numbers that do that. So that just means we're going to switch over to quadratic formula. So we have our a is 2, our b is negative 2, and our c is negative 5. So we're going to do x equals negative b, so that'll be positive 2 there. Because b is negative, we put a positive. Plus or minus the square root of negative 2 squared. Minus 4 times 2 times negative 5, and then all over 2 times 2. And so I get x equals 2 plus or minus the square root of 4. And then we have, let's see, negative 4 times 2 is negative 8. Negative 8 times negative 5 is positive 40, all over 4. We have 2 plus or minus the square root of 44 over 4. And then I got to break down that 44. So it's going to be 2 and 22, which will be 2 and 11. And then 11 does not break down. So we do have twin 2's there. So we'll say this equals 2 plus or minus 2 radical 11 all over 4. And then we can reduce these three numbers together. And so that's going to be, we're going to divide them all by 2. So that'll be 1 plus or minus radical 11 all over 2. We don't need it to write 1 rad 11. You can put that 1 there if you want, but we do need this 1 out front here because it's adding. So 1 plus or minus radical 11 all over 2. All right, number 13, we have again here. Our one side is already to 0, so I'm going to go ahead and draw my x. We're going to try factoring. If it does not work, we'll use quadratic formula. So a times c here would be negative 50, and then b would be positive 5. So let's see, for 50, we have 1 times 50, 2 and 25, 5 and 10. Oh, 5 and 10 will work. So I'm going to do a positive 5. Nope, I'm going to do a negative 5 and a positive 10. Because it's got to add to a positive 5. All right, so we'll split up this middle term then. We'll just rewrite this first term, 2n squared minus 5n plus 10n, and then bring this one down as a negative 25. We'll do our grouping here. So the first group, I can just take out an n, which leaves me with 2n minus 5. And then the second group, I can take out a 5, and it's a positive 5. Since that first term is positive, that'll leave me with 2n minus 5 as well. And then so we'll do n plus 5 times 2n minus 5 equals 0. Then remember, we need to split this up and solve it twice. So I'm going to say n plus 5 equals 0, and then 2n minus 5 equals 0. So n equals negative 5. And then, let's see, if we add the 5 over here, 2n equals 5, and n equals 5 over 2. So there we go. All right, we're going to go ahead and skip numbers 14 and 15. Okay, so lastly here, we're going to do some graphing. And so it says factor use a quadratic formula to find the x-intercepts. So for the x-intercepts, it's really like we turn y into 0. And so it's really kind of like the last problems we did. So we're gonna try factoring that doesn't work when we're going to use quadratic formula. So for this one, we have a times c. Now this one, a is actually -1, so you got to be careful there. So it's going to be -3 on top, and then -2 on bottom for b. So it's going to be -3 and +1. So then I'm going to rewrite this as -x squared minus 3x and plus 1x is how I'm going to split up that middle term, plus 3. So then we're going to use our groups here. So we got that and that. So the first group, I'm going to take out a -x, since that first term is negative. That's going to switch the signs here, so this is going to be x plus 3. The second group, I have to take out a +1, since that first term is positive. So it's going to be -x plus 1, x plus 3 equals 0. And so I can split those up and set them equal to 0 individually. So -x plus 1 equals 0, and x plus 3 equals 0. I'm going to subtract the 1, so -x equals -1. I'm going to divide by -1, so x equals 1. And then over here, I subtract the 3, so I get x equals -3. And so then as you can see here, that really does match up with what the graph shows, because we have an x-intercept there at -3 and at +1. So that's kind of why we do this, to see where it's going to hit the x-axis. All right, next up here, number 17. So for this one, once again, we'll plug in a 0 right there for y, and we'll try to factor this. So a times c is 30, and then b is -12. And so does that factor? So 30, what do we have? We have 1 times 30 is not going to work. 2 times 15, no, that subtracts to make 13. 3 times 10 doesn't work either. 4 doesn't work. 5 times 6 does not make 12 either. So does not factor then, so we'll just have to use quadratic formula. So we have, so we'll do x equals -b, so it's going to be +12, plus or minus the square root of b squared minus 4ac, and then all over 2a. All right, so then we'll go ahead and say 12 plus or minus the square root of 144 minus, and then 4 times 2 is 8. 8 times 15. That's a tough one. It'll be 120 all over 4. So square root of 24 over 4, which we can break that down. It'll be 6 and 4, which is 2 and 2, and then 2 and 3. So we have twin 2's are going to go outside. The loner 2 and loner 3 are going to go back in the house. So we get x equals 12 plus or minus the 2 rad 3. Oh, excuse me, that's not rad 3. There's a 3 and a 2 there. So let me fix that. That should be rad 6. All right, here we go. And that's all over 4. So we can go ahead and reduce that. Dividing all those numbers by 2, that's going to give me 6 plus or minus radical 6 all over 2. If you're thinking we can reduce more, we actually cannot. We're not allowed to reduce these ones unless we're also reducing with a number in front of the radical. We're not allowed to reduce a number inside the radical. So that's it. We're actually done with this. But just to show you something cool here, I'm going to, because we don't know what that kind of number is as a decimal, so I'm actually going to use a calculator to figure that out. We're not going to have to do this on a test, but I just think it's cool to look here. So on a calculator, there's no plus or minus button, so I'm just going to have to do that twice on the calculator. So the first one, I've got to use parentheses here, so I'm going to say 6 plus radical 6 divided by 2 and see what that is, and then I have to do it again as a minus. So that's how you do the plus or minus on a calculator. You just have to do one of each. And that's really how we get our 2 answers. So let me type this into the calculator and see what we get here. So for the first one, I get about 4.22. And for the second one, I get 1.77. And so if you kind of look at where this graph hits the x-axis, right here and right there, I would say that those are very reasonable answers there, 1.77 and 4.22. So that's pretty cool that that matches up there.